All right, welcome to the first video lecture for Honors Pre-Calculus. This week's lectures are going to be broken up into 3 lessons. That's going to be typical for pretty much all the weeks that you have coming up. In these 3 lessons, they should take you about 30 minutes to watch and then do the exercise. And this week, we're just doing review. So how we're going to do that is we're going to go over the Unit 8 exam, and then I will give you problems similar to the ones on the Unit 8 exam, and you'll have each lesson will be 5 questions long. When you're answering those questions, you can type your answers into the Google Doc in Classroom, or if it's easier, you can just write the answers in your work on a sheet of paper and then scan it or take a picture of it and email it to me. Really, as long as you submit your work to me in a way that I understand what problems you did and the work and answers that you got for those problems, I will accept it. And if there's problems, we can talk about that. The other thing you should know for the start of these online classes is we will have Zoom hours. Those are posted in the Google Classroom. I believe for first hour, it's going to be 9:30 to 10 on Mondays. For third hour, it'll be 9:30 to 10 on Tuesdays. So that will also be during a geometry office hour. I don't know how many people are actually going to go to those. So for third hour pre-calculus students, you can try then. But if the first and fourth hour times work better for you, that's fine. And then the fifth hour ones will be 9:30 to 10 on Wednesday. If any of those times work for any of you, you don't have to, if you're in first hour, you can stop in for the third or fifth hour one. If you're in fifth hour, you can stop in for the first and third hour one. It doesn't really matter to me. I will also be hosting office hours on a Thursday and Friday from 9:30 to 10:30. That's a free for all. Anyone could show up to those. And those are there for you to hop into a video conference and ask any questions you have about the material, and then I can go over it for you. If you have any questions about any of this process, feel free to email me and I'll answer or stop in during those office hours and I'll be able to help you out. Okay, now let's start the real deal. Let's do the first lecture in Zoom. So we're just going to go through the first 5 problems of the Unit 8 exam. The first question says a sector of a circle has a radius 10 and central angle of 20 degrees. Find its approximate arc length and its area. In order to find arc length, you have to use the following formula because our problem is in degrees. The arc length is going to be the angle that they give you divided by 180 times pi times the radius. So for our problem, that'll be 20 degrees divided by 180 times pi times 10. And if you did that correctly, you should get 10 pi over 9 feet. Or if you rounded that, I would also accept 3.491 feet. For doing these calculations, by the way, there is a TI-84 emulator. I don't know if I posted that to the classroom yet, but if not, I will after this. I'm done recording this video. So when you check in there, there's an emulator that you could download to your Chromebook, or if you're using your own Mac or PC, it works on those too. And it'll give you a calculator that looks just like this that you can use. So, I mean, if you have one on your phone, you can use that as well. The second part of this problem asks us to find the area. In order to find the area, which we denote by the letter K, you're going to take the angle divided by 360 times pi r squared. Sounds like area to me. And the way to remember that formula, by the way, is this is just the area of a circle, right? Pi r squared. Theta divided by 360 is the portion of the circle that's covered by this sector. So you could think it's just the area of the circle multiplied by the portion that's covered by that circle. So again, if we plug in the numbers we're given, it's going to be, oh, I did forget little degree symbols here. It's going to be 20 degrees divided by 360 degrees times pi times 10 squared. And if you did that correctly, you could get 50 pi over 9 feet, or feet squared, or approximately, if you go to 3 decimal places, 17.453 feet squared. That's 17. 17. Nobody's going to think that that's not a 17 because look how 17 it is. That's the most 17 I've ever seen a number. All right, so that's number one. You just got to keep in mind when you're doing number one that the problem they give you is in degrees. So you have to use the two formulas for arc length and area, that was degrees and not radians for your angle. Number two. For number two, we're told that there is a giant statue of a goldfish, normal, about 20 meters from you, and its apparent size is about 0.5 radians. Okay, so here's you. This is you. You. All right, 20 meters from you, there is a goldfish. Okay, and oh, okay. The apparent size. So the idea behind that again is the angle that this object makes with how it appears in your field of vision is this takes up 0.5 radians. So the question is what is the approximate height of the goldfish? Well, to find the approximate height, we're going to use this trick where we say the approximate height is about the same as this arc length that's created from this sector. So we can say the height of the goldfish is about the same as the arc length. And the formula for finding arc length when your angle is in radians is just your angle times the radius. And for us, the radius of this big circle is how far you are from the goldfish, and we are 20 meters from the goldfish. So this will be 0.5 times 20, which is 10 meters. Yay. Again, that one's in radians, so you have to use the formula for arc length for an angle in radians. Number three. So for number three, we are told that the cosecant of an angle is 8 over 5, where the angle is between pi over 2 and pi. Find the values of the other 5 trig functions. So this problem requires you to know what your 5 trig functions are. The sine of an angle is the y value over r. The cosine of an angle is the x value over r. The tangent of an angle is y over x. The cosecant of an angle is just the reciprocal of sine r over y. The secant of an angle is the reciprocal of cosine, so it's r over x. And the cotangent of an angle is the reciprocal of tangent, so it's x over y. And if you have a hard time remembering these, I mean, you can go back and refer to your notes or the book, but if you think, okay, here is a xy plane, right? And here is a point in the xy plane that has coordinates x and y. If we make a right triangle using the x-axis in that point, then this angle here, theta, uh, is what you would use to find all of these ratios using the same thing that you're using in geometry, where sine is the opposite side and the length of the opposite side is your y value. The adjacent side is the length of your horizontal component here, or your x value, and then the radius here is the hypotenuse, right? And so sine is opposite over hypotenuse, so it is y over r. So in order to find this, we have to know, okay, cosecant of theta is r over y. So we know in our problem, since cosecant of theta is 8 over 5, we know the top value, 8, is r, We know the bottom value, 5, is y, and the only thing we're missing to find all these values is what's x. Well, just like you would do in geometry to find x, the third side of this right triangle, I would use the Pythagorean theorem. X squared plus y squared is equal to r squared. Or x squared plus 5 squared is equal to 8 squared, which is x squared plus 25 is equal to 64. 25 minus, or 64 minus 25 is, so that'd be 59, 39. And so x is the positive plus or minus square root of 39. Now here's where a lot of people messed up on the Unit 8 exam, is this plus or minus. It's actually really not a choice in our problem because, again, remember our angle is between pi over 2 and pi. If you think about your unit circle here, right? 0 degrees is 0 pi. 90 degrees is pi over 2. 180 degrees is pi, right? 180 degrees is the same as 1 pi. 270 degrees is 3 pi over 2. And then 360 degrees is the same as 2 pi radians. So our angle is between pi over 2 and pi. So it's going to follow somewhere in this quadrant. And in quadrant 2, x has to be negative. So this is actually negative square root of 39. So now that we know that, we can go back and fill in all these answers over here. So we, erase. Cosecant we don't need to do again. We already know that one. Then we can just plug in. So sine is y over r, so it's going to be 5 over 8. Cosine is x over r, so it's going to be negative square root of 39 over 8. Tangent is y over x, so it'll be 5 over the negative square root of 39, except that is not really a valid answer because it has a radical in the denominator. You would fix that by multiplying the top by the square root of 39 and the bottom by the square root of 39. And then you would get on the top 5 square roots of 39. On the bottom, the square root of 39 squared, which is just 39. Secant is r over x, and you run into the same issue. So it would be r, which is 8, over x, which is negative square root of 39. But again, if you rationalize that, it's 8 square root of 39 over negative 39. And then last, cotangent is x over y, so it's negative square root of 39 over 8. Okay, so hopefully that can help you when you do number 3. The key thing is, again, just write your formulas and then find your missing x, y, or r value using the Pythagorean theorem and then plugging it in appropriately. If you have a radical in the denominator, make sure you multiply the numerator and the denominator by that radical to eliminate the radical in the denominator and rationalize your problem. All right, number 4. So number 4 is along the same lines. If you understand number 3, you'll understand number 4. The key thing is to know arc sine, remember, means sine inverse. So if the sine of an angle is y over r, then the inverse sine would take a ratio of y over r and give us an angle, where because we need to force it in order to be a function, that angle has to be between negative pi over 2 and pi over 2. Otherwise, it'll fail the horizontal line test, and then it will not be invertible. You don't really need to know that part for this problem. What we do need to know is that the arc sine takes a ratio and gives us an angle. So this is going to give us some angle. And then the cotangent of an angle, remember, will tell you the value of x over y. So this is going to give us the answer finally. When we take the arcsine of this, it'll give us an angle. When we take the cotangent of that angle, it'll give us an answer of x over y. So the only thing we need to know to find this answer is what is x, because we already know what y is. Y is 8, right? The arcsine takes a y over r value, which means y has to be 8 and r has to be 17. And if we know y is 8 and r is 17, we can find x by doing the Pythagorean theorem again. X squared plus y squared equals r squared. So x squared plus 8 squared will equal 17 squared, which is, I don't even know. Let's type that in the calculator. So it's going to be the square root of 17 squared minus 8 squared, which is 15. So x will equal 15. And keep in mind, because this is between negative pi over 2 and pi over 2, x will be positive. So the cotangent tells us x over y. So x is 15, y is 8. So the answer is 15 over 8. Yay. All right, last one. Number 5. Write a linear equation with inclination of 42 degrees and through the point negative 4/8. In order to write a linear equation, you need to know two things. You need to know a slope and a point. So in order to find those two things, we're going to use what they give us. And look, they already give us the point. So we know x1 and y1. x1 is negative 4, y sub 1 is 8. All we need is the slope. Well, how do we find the slope? I bet you this is going to have something to do with it, right? The inclination tells us the angle that we pass through the x-axis, right? So this line has an inclination or makes an angle of 42 degrees with the x-axis. So in order to find the slope, we need to find the rise over run. Well, that should look really familiar to you. Y over x, isn't that the same thing as the tangent of our angle here, right? Will give us y over x. So if our angle is 42 degrees, we'll take the tangent of 42 degrees, and that will give us our slope. And so we just type that into a calculator. Make sure your calculator is in degree mode. So you hit mode, make sure this third line here says degree. And then we're going to take the tangent of 42. Our slope is 0.9. So slope is about 0.9. So then now that we know our point and we know our slope, we can write our equation in point slope form. So y minus 8 equals 0.9 x plus 4. And you're done. You have written a linear equation. You don't need to put that in slope-intercept form. You're done there. All right, if you have any questions over this video, you can stop in during office hours, pretty much any time this week during first, third, or fifth hour, or during Thursday or Friday from 9:30 to 10:30. Or if you want, if you prefer, you could just email me. All right, thank you all for watching. And hopefully, if you use this notes alongside when you're doing the lessons, and you can pause it and then work on a problem, move on to the next one, pause, work on a problem. Hopefully, the lessons won't be so too bad. The other thing is, if you take notes over these lessons just like you would do in class, it'll probably make your life a lot easier, and you'll have to go back and watch the video less and be able to rely on your memory and your notes more because that physical act of writing helps create neural connections in your brain, which helps you remember stuff when you are asked to recall information. All right. Thank you all for watching.